One more special feature of a graph that we need to investigate is what's called the average rate of change. And all it is the description of how fast the output is changing in comparison to how fast the input is changing. The change in output over the change in input. Now remember, output is our y values. So I could also say change in input is the same thing as change in y, or delta y. And change in x, or change in input, is the same as change in x, delta x. And maybe this would be more familiar to you even if I say change in y would be y2 minus y1 over change in x, x2 minus x1, which is essentially the formula for finding the slope of a line. Now, the slope of a line is a constant number. There's no changes in a line. It doesn't start to go curvy. It's just straight all the time. So the slope stays the same. But if we've got a curvy graph, like this W that we have graphed here, the average rate of change is going to be different at different intervals of our graph. So we're going to narrow down to some smaller intervals. Our first one we're going to do is -3 to -1. As our x values. So first thing that I look at is -3 to -1. Notice as we read from left to right, our function is decreasing there. So that tells me my average rate of change is going to be negative to show it's going downhill. And then my change in y over change in x, I'm going to get my point values up at this point when x is -3, y was +3, and at -1, y value is -3. So that tells me my change in y, I started at 3 and ended up at -3, that's a distance of 6 spots. Or I could count down, 1, 2, 3, 4, 5, 6, and then I'm running 1, 2. Or to go from -3 to -1 in my x values, that's a distance of 2. And we could reduce -6/2 to -3/1, which would tell me for every x value I am increasing, my y value is decreasing by 3. The next little section that we'll look at is what happens on the graph between -1 and 0. Well, here's -1, here is 0. Notice the graph is increasing, going uphill, so that means my average rate of change is going to be positive. And then my value of my relative max here, my turning point up here, is at 0, 1. So my y values, I've went from -3 to +1, which is a distance of 4. Or I could have just counted 1, 2, 3, 4. And then from -1 in my x value to 0, my next x value, that's a distance of 1. And there's my average rate of change, 4/1. The next interval from 0 to +1 will be pretty easy because notice from 0 to +1, what's happening there is just a mirror image of what happened from -1 to 0. So our average rate of change is going to be 4/1. But now that'll have to be negative because our function is decreasing between 0 and -1, or 0 and +1. Lastly, on this graph, from -1 to 2.25. Our average rate of change is going to be positive because our graph is increasing there. And then our change in y, well, we started down at -3 and we ended up at the x-axis, which means we traveled a distance of 3. And our y values, our x values, we started at +1 and ended at +2.25. So that would be a distance of 1.25. We don't necessarily have to be looking at a graph to figure out average rate of change. We just need to know some points. So take this XYT chart, for example. I want to know the average rate of change between 0 and 4. Well, the change in y, we have went from -8 to -9, which is a decrease of 1. So there's my change in y. And my x values have went from 0 to 4, which is an increase of 4. So my average rate of change is -1/4. So for every increase in x, the y is dropping a quarter. Between +4 and +10, our y values have went from -9 to +32, so that would be an increase of 41. And our x values have went from 4 to 10, which is an increase of 6. So our average rate of change is 41/6.